So firstly we will introduce what is the chemical bonding. Basically chemical bonding explain how the atoms combine to form the molecules and compounds. Atomic bonds to achieve the stability by completing their outer electron shells. These bonds hold the atoms together and determines the properties of the substances. The three main types of the chemical bonds are ionic, covalent, and metallic bonds. Ionic bonds is especially important in forming the salts, minerals, and the biological electrolytes, and it is essential for understanding the chemical reactions and material properties. Firstly, we define what is the ionic bonds. Basically, an ionic bond is formed when one atom transfers the electrons to another, creating oppositely charged ions that attract each other. They usually occur between the metals, which lose the electrons, and nonmetals, which gain the electrons. Ionic bonds are strong and non-directional, giving compounds high melting and boiling point and a crystalline nature. The example of the ionic bond is the sodium chloride NaCl. Sodium lost an electron to chlorine, so the sodium have the positive charge and the chlorine having the negative charge. Magnesium oxide MgO, where the magnesium loses the two electrons to oxygen, the magnesium have plus 2 charge and oxygen having the minus 2 charge. There is some historical background about the ionic bond, such as the concept of ionic bond developed gradually or scientists explore the atoms and electric charge. In the early 19th centuries, Michael Faraday studied the electrolysis and observed that compounds could conduct the electricity when molten or dissolved in water. His work showed that electricity is linked to the chemical changes. Later J.J. Thomson discovered the electrons, which help explain how the atoms can gain or lose the electrons. Rutherford and Bohr developed the atomic models that further clarified the electron arrangement in atoms. The concept of valence electron was introduced to understanding the bonding patterns, so scientists realized that electron transfer form oppositely charged ions. These ions are held together by strong electrostatic forces, forming the ionic bond. So over time, the concept of the ionic bond becoming a well-established principle in chemistry. Today it is essential for explaining the behavior of many inorganic compounds. So there is some importance of the ionic bonding, such as the ionic bond explain how the atoms form compounds and determine their properties. It is essential for understanding the substances used in life and industry. Sodium chloride is an ionic compound important for human nutrition. Many minerals in the earth crust are ionic compounds shaping geological formations. Ionic compounds are widely used in medicine and pharmaceuticals. They are important in agriculture such as the fertilizer and soil nutrients. These ionic bonds play a role in manufacturing and industrial process. Understanding the ionic bond helps the scientists to predict the chemical behavior and design the new materials. So overall, ionic bond is vital for chemistry, biology, and the technology. Now we define the valence electrons and octet rule. The valence electrons are the electrons in the outermost shell of an atom and determine the chemical bonding. The octet rule states that atoms gain, lose, or share electrons to achieve a stable 8 electron configuration. So, in ionic bond, atoms transfer the electron instead of sharing them. So, metals lose the electrons to form the cations, while non-metals gain the electron to form the anion. So, this is the octet rule where the explain the state of atoms which gain, lose, or share electrons to achieve a stable 8 electron configuration. Now, what is the formation of the ions? Basically, ions are charged particles formed when atoms gain or lose the electron. So when an atom loses one or more electron, it becomes the positive charge and it is known as the cation. When an atom gains the electron, it becomes the negative charge and it is known as anion. So the formation of ions require the energy changes which are influenced by ionization energy and electron affinity. So ion formation is a key step in the creation of the ionic bonds. Ions are charged particles formed when atoms gain or lose the electrons, right? So this is the basic nature of the formation of the ions. So now what is the process of ionic bond formation? Basically the formation of the ionic bonds involve the several steps including the electron transfer, ion formation and electrostatic interactions. For example, in sodium chloride, the sodium loses one electron to form the sodium while chlorine gains one electron to form the chlorine ion. So these positive charge ions attract each other forming a stable ionic bond and this process results in the formation of ionic lattice rather than the individual molecules. So what is the energy changes in the ionic bond? Basically energy changes play a significant role in the ionic bond formation. Ionization energy is required to remove the electron formed in atoms, while electron finally release the energy when an atoms gain the electron. So the overall energy changes determine whether the gain bond formation is favorable. So the lattice energy released during the crystal formation stabilize the ionic compounds. Now we define what is the lattice energy. Lattice energy is the energy released when gaseous ions combine to form ionic solids. It is measure of the strength of the ionic bonds. So higher lattice energy indicate the stronger attraction between the ions. So the factors affecting the lattice energy include the ionic charge and the ionic size. So there is some factors which affecting the ionic bond formation such as the several factors which influence the ionic bond formation including the ionization energy, electron affinity, lattice energy and atomic size. So elements with the low ionization energy and high electron affinity are more likely to form the ionic bonds. The difference in the electronegativity between the atoms also play a crucial role. There is some properties of the ionic bonds. Like ionic bonds have distinct physical properties such as the high melting points, hardness and brittleness. They are usually soluble in water and insoluble in the non-polar solvent. So these properties arise due to strong electrostatic forces between the ions. Now, what is the electrical conductivity? Basically, the ionic compound conduct the electricity when molten or dissolved in water. In solid form, ions are fixed in places and cannot move freely, while when molten or dissolved, the ions become mobile and carry the electric charge. There is the solubility of the ionic compound. Like the solubility of the ionic compound depend on the balance between the lattice energy and hydration energy. Water being a polar solvent, so stabilizes ions through ion diploid reactions. High soluble ions compound readily dissociate in the water. There is the examples of the ionic bonds. Like common example of ionic bonds include the sodium chloride, potassium bromide, calcium oxides, and magnesium sulfate. So these compounds are widely used in daily life, industries, and the medicines. For example, it demonstrates typically ionic bond characteristics. There is the comparison with the covalent bond. Like ionic bond different from the covalent bond in that electrons are transferred rather than shared. So covalent bond usually form between non-metals with similar electronegativity. Like ionic compounds are generally harder and having higher melting point than the covalent compounds. So there is the role of the ionic bonds in the daily life. Like it has been essential in daily life through salt, medicine, fertilizers, and cleaning agents. These electrolytes in the human body rely on ionic compound to transmit nerve signals. So household products such as the baking soda and bleach are ionic compounds. There is some biological importance of the ionic bonds. Like in biology, ionic bonds play a crucial role in maintaining the cell functions. So, sodium, potassium, calcium, and chloride ions are essential for nerve transmissions and muscles constructions. Ionic interaction also stabilize the protein structure and enzymes activity. There are some advantages and limitations of the ionic bond. So, ionic bonding properties strongly attraction and stability to the compound. However, ionic compounds are often brittle and may not conduct the electricity in solid form. So, understanding these limitations is important in material science and the chemistry applications. So, as a conclusion, ionic bond is a fundamental concept that explains the formation and behavior of many important compounds. It involves the transfer of electron, formation of ions, and a strong electrostatic attractions. So, ionic bonds influence the physical property, biological process, and industrial application. A thorough understanding of ionic bonding is essential for students of chemistry and related science.